Hi everyone, my name is Donciu-Julin. I'm an AI software engineer, fresh out of school. I just completed a 9-week bootcamp on AI engineering at Ironhack. And as part of the bootcamp, during the last week, we were asked to build chatbot. And I decided to push the project a little bit further and simply not just make a Q&A chatbot, but actually build an avatar on the subject of literature. So I grew up with books. I have, to the top of my mind, always had a book in my backpack, and I started imagining how we could build the library of the 21st century. How could we bring people back into libraries? How could we raise the desire of people to read, especially young audience, like kids today prefer video games as reading books? And how could we help them by how could we revolutionize book discovery through AI and build chatbots that will be available in libraries, bookstores, etc., and with whom people would be able to interact, share about book, share about their favorite section, discover new books, matching their preferences, and simply exchange, like share and exchange, and have an experience simply talking to someone about their favorite book. This was the pitch of the project. I'm going to give you a gross overview of it. So on the paper, we were asked to build a multimodal AI chatbot and implement a RAG system, so retrieval augmented generation system. The chatbot using the RAG system should be able to retrieve YouTube transcript and answer questions about them. The RAG system should give our chatbot access to a vector database, and the chatbot should be able to store and retrieve information from the database. Ideally, we should be able to use speech and text to chat with the chatbot, with the avatar. And we were asked to evaluate as best as possible our chatbot using tools like Langsmith or Giscard. I worked 7 days on the project and I was all alone. All right, here's a technical summary of my project. So on this flowchart, you can see yourself as a user. You interact with my avatar. She's called Alice. I will present you in a moment. So Alice, you have access and you can interact with Alice via a Flask interface on your browser. You can use voice or text input to dialogue with her, and she's answering you using voice answers. At the core of my avatar, of my chatbot, you have a Langchain agent. I'm using the Langchain frameworks to define an agent fully controlled by a large language model. In my case, I'm using GPT-4o Mini. The large language model is using the agent to answer the user. The personality of my chatbot of Alice is defined inside a prompt. And inside the prompt has access to a conversational buffer memory, window memory. So it is able to remember the whole conversation. As I said, the large language model via the agent has access to a RAG, retrieval augmented generation system. So the RAG consists of a set of tools that allow my agent to fetch information from outside the reach of the large language model. So if my LLM doesn't know an answer, if it cannot fully understand the user query, it has some tools to fetch this information from outside. The main one being to access its database, so it's able to store and retrieve information from the database, book information and book reviews. But it's also able, using the Wikipedia API, to fetch information from Wikipedia, mostly book information, and using the YouTube API to retrieve book reviews from YouTube. All of this enhanced context that you see in red is actually gonna be is actually going to be added to the prompt and the query, and used by the LLM to generate a more precise answer, an answer that is actually using a broader context that it fetched from outside. And this answer is then going to flow back to the user as a voice answer. Quick note that I initially challenged myself to open source the whole solution. So maybe this is coming from the fact that I think literature should be free. In my head, everything related to open source, so literature should be open source. And I initially wanted to use only open source solution. This is why I started by using Google, the speech to text from Google and the text to speech from Edge, which are fully open source. And I use ChromaDB as the database, which is also an open source solution. However, after spending 1.5 days trying to fine-tune Mistral, the open source Mistral 7b, the open source model from Mistral, I had to step back and rely on GPT-4o for the rest of the project. Mostly because when using Mistral, I had to use my solution on Google Colab, and it was very intensive performance-wise. It was quite intense. I had to use Colab, but using Colab, it was hard to develop a Flask application, and I had in the end to step back on GPT-4o Mini for the rest of the project. But I'm still hoping that Alice could one day be fully open sourced. Now let's talk about the dataset. Initially, I had the idea of starting with a blank database. My idea was that Alice would have an empty database at first, and she would be learning through her interaction with the reader. So as every time she's fetching information to answer a question, she's saving this information into the database to be reused later. However, it came to my mind that she would be quite a lazy librarian if Alice would be a lazy librarian if she has to query Wikipedia about any book to retrieve any book information. Since her personality says that she's spending days reading books and she's like actually literature is all her life, she should actually have some knowledge about books. So yes, and another thing that came to my mind is that she might actually have no access to internet at some point. So by losing her RAG capacities, she should still be able to fetch some information. And I didn't want her to rely only on the LLM knowledge. I wanted her to be able to fetch this information from somewhere. So this is why I searched for a data set of books, and I found one on Kaggle that has about 103,000 books. That's this one here, the book data set. And the book data set is providing information about title, author, description, category, published date, publisher, price for the 100,000 books. I dropped the last two columns that are of no interest to me at the moment. I simply want to discuss books and books content, not about publisher price. And what I've done also is to drop any entries, any rows that don't have a description, mostly because if an entry, if a book doesn't have a description, it's a bit tricky for Alice to use it still. So since I'm using this, since the description is the part that I'm vectorizing, I dropped all the rows that don't have a description. I ended up with 70,000 books, vectorized the description, and passed the rest of the books as metadata. And I stored all of this in the Chroma database, and this allow Alice actually to now query her database and find most of any books you can ask her about, except for recent one, she will be able to answer and at least provide the plot and discuss the main characters and things like this. Now let's have a look at the agents. This is the core of the project and the interesting part. Alice is I'm using for Alice a Langchain agent, an agent executor, or so to say a tool calling agent, which is an agent that is able to call tools, to use tools, so Python functions to fetch information from outside and enhance its own context. My LLM, so at the core, as I said, at the core of my agent, I have GPT-4o Mini as a large language model. The personality of Alice is defined inside the prompt. So this is where I list all her personality and all of the instructions that she should follow. the prompt is linked to a conversational buffer window memory, so Alice has access to some kind of history, so of chat history. She is able to remember the last conversation she has, and as long as the conversation is running, she is storing the system, the user and the chatbot messages inside her prompt. And as submodules, I'm using two submodules to help summarize and grade the answer the agent is giving. First of all, I'm using a summarizer. So this one is very useful, for example, when we retrieve information from YouTube. Even Wikipedia, I think I'm using it for Wikipedia and mostly for YouTube transcript, because the transcript of YouTube are very long. Using a summarizer is a great way to summarize the content and only keep information related to the user query. And I'm also using a relevance grader, also based on GPT-4o Mini at the moment, that is making sure that it's grading the answer the LLM is about to return. So it's making sure that the answer is answering the question, and if the grade doesn't pass, then it's not sending the answer, and instead of this, it's answering that it doesn't know. Again, as I was planning to use open source solution for this too. I used an open source solution for the summarizer at the beginning. I use a Hugging Face model to summarize the information return, but I switched back to an LLM solution because I'm not only summarizing, but I'm also, as I said, summarizing and only keeping information related to the user query. So, for example, if in Wuthering Heights you are asking about the evolution of Heathcliff, I don't want my model to fetch information and summarize the plot of Wuthering Heights. I want it to summarize the plot of Wuthering Heights by putting an accent on the character of Heathcliff. So it's not just give me a summary of the plot, it's give me any information in the plot, summarize me please any information of the plot related to the character of Heathcliff. So this is why I switch back to an LLM solution, because the LLM is a little bit better at understanding, at summarizing something in relationship with something else, being the query. Same for the grader. All right, now let's have a look at the tools. So as I said, the tools are part of the retrieval augmented generation part, and are used by the LLM, by the agent, by the large language model through the agent to retrieve information from outside the reach of the large language model. The first one, so I'm using 6 tools. The first one being tools to access the database, so the Chroma API. I'm using and embedding models to encode my queries and retrieve and decode my retrieve information. And I have 2 tools to fetch book information and book reviews. I separated the two into my database to make sure they don't mix up, because book information is very factual. It's just information about the book, while book reviews is more about the point of view of people and YouTuber in particular. So I'm trying to keep those separate. And my agent is able this way to fetch vector search for book information, for book review, and filter the result based on Euclidean distance to make sure that the information retrieved is matching the query. On the right side, you have the YouTube API. So I have 2 tools here. The first tool is searching YouTube for book reviews. So if I ask Alice, for example, what do people think about Jane Eyre, she's able to go to YouTube, find some book reviews, summarize them using the submodules that we just discussed, and compare and return like a summarized answer. She's also able to retrieve directly a video transcript. So if I say, hey, I want to discuss this video, and give her the link, she's able to go retrieve the transcript, summarize it, discuss it, and then store, if it makes sense, she would store the results, the review, or the book information into her database. Same with the Wikipedia API. So I have one tool that is searching the Wikipedia for book information. summarizing the result based on the query using the submodules, and if matching, if related, she can store the result in the database if relevant. Finally, I have one little tool that's actually the first one I implemented as a test. It's a Who Are You tool. This is a tool for Alice to fetch information about herself. So if I'm asking her, like, tell me about you, what do you like reading, what's your favorite book, what are you reading right now, what did you do today, it's all information about her. That's like, it's a text file, maybe like 50, 60 lines with anecdotes, information about her. It's a way to alleviate the prompt. It's a way to make the prompt a little lighter and not provide too much information about her in the prompt, not swarm the prompt with information about her, but simply have all this information aside and she can just pick into it if the readers are asking. Okay, now let's move to evaluation. So evaluation took me about 1.5 days. I had a lot of fun working on that. It's not easy to evaluate a large language model. It's not easy to evaluate an agent and a chatbot. And I use 3 different techniques: prompt fine-tuning, evaluation using Giscard, and evaluation using Langsmith. The prompt fine-tuning is something that this is the first thing you do when you develop your agent. Is how can we forge Alice's personality using her prompt. So I worked a lot. I spent a lot of time fine-tuning her prompt. I tested different techniques, different prompt lengths. In the end, I should have a prompt somewhere here. Here, prompt JSON. In the end, I relied on a very short prompt. I find it short compared to what I've tried. So this is about 10 lines, and it's 10 system messages. Oops. Listing everything about her job, everything about what she should do, how she should answer, how she should treat some unrelated question, how she should use her tools to fetch information, and finally the important thing she should pay careful attention to. From all my tests, what I retain and what the takeaways are that short and concise prompt work better. If you swamp your prompt with information, especially from small models like 4o mini, the model tends to forget or tends to get confused. And when I had a lot of redundant information, the model was actually not respecting it in the end. So I found out that short and concise prompt work better. There is no need to explain the tools. That's actually what your doc strings are doing. So if you have a very well described doc strings to your tools methods, that's enough. But you need to explain to the large language model the priority, the tool called priorities. So I had to explain to Alice, please first check your database before you go to Wikipedia or YouTube to fetch information. Like, don't retrieve information that is potentially already in your database. So you need to make very clear to the chatbot the order of tool calls, the priorities. I found it very useful to insist and repeat the important point, especially at the end. Anything at the beginning tends to be forgotten, while things at the end have more weight for the LLM, especially again for a small model like GPT-4 mini. Caps help, I don't know. It's like, maybe psychologically speaking, I had the feeling that putting stuff in caps is actually helping. I'm not sure if the LLM actually, through the learning phase, came out to understand that capital letters actually make things more relevant. Should read some papers about it. But psychologically speaking, it helped me a lot. Okay, Giscard, something I've done the last day is it's framework. It's a great framework to evaluate your agent. And what it's doing, for what I understood, is that it's using another LLM. It's using a large language model that is going to grade and evaluate your language model. For this, however, you cannot use it straight out of the box. You need to create a data set for that. And what I've done is I created a data set of 100 book titles and description. And I gave this to Giscard, and it ran some reports using those book titles and description. It started questioning Alice, questioning my chatbot, my agent, and to try to with like sneaky question to try to corner the problem. The main report you can run, the fast one, is the hallucination report. This is a way to see if your model hallucinates. So in my case, obviously, after so little time spent on her, she was hallucinating. For example, it asked about the Invisible Pink Unicorn book, or it asked about The Martian Chronicle by William Shakespeare, and well, my chatbot was not able to correct and say, hey, this is not from Shakespeare, this is from Ray Bradbury, or the Pink Unicorn, Invisible Pink Unicorn book doesn't exist. So it has unfortunately hallucinated and gave very precise description of this Invisible Pink Unicorn book. And something that I found super useful and very interesting is the full report. So make sure you have enough credit. It's using your OpenAI credits to run the reports, and it cost me about €1, which is not a lot, but again, I only ran it for 100 book titles and descriptions, so my dataset was very, very small. If you have a large dataset, it can go into the 10, 15, 20 euros, so be careful. And what it's doing is that it's going way more in depth. The large language model used by Giscard is really, really trying to corner your model and is really trying to make it do something to fault it. And what came out of this report are two things. I had the hallucination again, and first of all, I was very surprised and confused that Alice, my nice librarian girl, spending her days in pajamas reading books, is actually generating harmful and toxic content. So the Giscard LLM asked about the dangerous substance described in the book Fear and Loathing in Las Vegas, and Alice gave a lot of information about those dangerous substances. So yeah, this is not something you want, obviously. I mean, you've all played with ChatGPT, and ChatGPT, if you ask about something like that, it's gonna say, I'm not gonna discuss things like this. This doesn't belong to the subject I'm allowed to discuss. But my Alice had absolutely no problem discussing those substances while she is controlled by GPT-4o Mini. So this is still interesting that while she's using GPT-4o Mini and ChatGPT-4 would not discuss those substances, she's still discussing them. Another one, but this is a bug I had all along the project, is that sometime, especially when querying information from YouTube, she gets confused, and there is a bug that she starts blabbering some random characters, even some Chinese, Sanskrit or Arabic characters, and she just doesn't stop until she hit the context window size, which must be 4 or 16K, forgot. And I got as an answer, as an evaluation, that the agent's response is incoherent. This doesn't happen a lot, but yeah, I'm still working on it to understand where it's coming from. So yeah, anyway, the Giscard evaluation has been very useful, and it's great to actually give you some feedback you did not necessarily expected, and you did not really know how to test, how to mention. The other evaluation set of tests I have done is that I actually did some research online. I spent some time on ChatGPT to try to list all of the tests that make sense on how to evaluate a large language model. And these are the tests that came out. I ran for 3 different tools. I evaluated the fetching database information from the database, fetching information from Wikipedia and from YouTube. And I ran for all of the 3 tools, I ran the set of tests, all of these tests. The mean response time, so it's pretty obvious, is how fast my chatbot is answering. So you can see it's pretty fast when fetching information from the database or Wikipedia, but YouTube takes much longer, mostly because the transcripts are very long. The mean answer score and the mean sanity check, on those 2 tests, I am using an LLM, so I'm using a GPT-4o Mini, I think, to score the answer based compared to the query, so to see if it's answering the query properly. And the sanity check is actually only checking if I am answering the question or not. So I have an LLM assessed if my answer is answering the question. As you can see, the results are more or less the same. The best score I have are from when fetching information from Wikipedia, mostly because it's kind of obvious. When you get information from Wikipedia, you rarely have it wrong. It's either the Wikipedia page is found and then the information is returned, summarized, and then it's answering the question. It's more, or it's happens after that the YouTube answer is less relevant or is not actually really answering the question. So I get better rates on Wikipedia and the database than on YouTube. The mean semantic overlap, this one doesn't really make sense here. It's I think I'm using cosine similarity. I'm using mean similarity to compare my answer and the description of the book. So what I'm doing is that I'm asking my agent to fetch the plot of the book and to summarize, like to return me the plot. It's doing that by getting information from the database, getting information from Wikipedia or from YouTube, and then I'm running a similarity check. So I'm comparing the vector from the responses and checking if the cosine similarity is checking the cosine similarity. It doesn't really make sense here because I'm comparing it with the description stored in the database. So obviously the database is returning a better score than Wikipedia and YouTube. But still, it was interesting to run the test. The readability score is something I didn't know, so it's called the Flash Reading E score. I have it somewhere. This is a way, yeah, that's the one. This is a way to evaluate the difficulty, the level of the English answers. For example, my model, when producing answers based on database, Wikipedia, or YouTube, using one of the three tools, it's more or less the same, produce an answer graded with a mean of 23. And if you look 23, so between 10 and 30, the English language use is evaluated as college graduate, very difficult to read, best understood by university graduate. So it's a way to evaluate if Alice's answer can be understood, for example, from kids or from people with like less that has less university knowledge. I find it a bit exaggerated, maybe. Like, I don't think, like, when she's answering questions, she's a little bookish, but in her answers, but this is the purpose anyway, so she's actually giving information. I find her answer quite understandable, even for non-English speakers, non-natives like me. But still, also like an interesting metrics to consider. And on the bottom, you have the metrics coming from Langsmith. So when you run inference on your chatbot, you have metrics on Langsmith. This is very interesting also to extract those metrics. I had the mean latency and mean error rate, obviously. So the latency is like the response time, is how fast it gets to get an answer. Again, YouTube stands out to be much longer, especially because it takes time to retrieve the transcript, summarize them, and return them. And also the error rate is much higher on YouTube, but it's kind of biased by the fact we've seen it on the Giscard evaluation that sometimes my model produce erratic information, and this is just like false information that is evaluated as wrong. So this one doesn't really make sense as long as I haven't fixed this bug. And on the token and cost comparison, it's also kind of obvious that fetching information from the database, from Wikipedia, is actually the cheapest and producing the least amount of tokens. Database a little more, and YouTube itself produce way more tokens and cost a little more than the other two, mostly because of the length of the transcripts again. So again, that was a lot of different tests. I had fun running to get like to evaluate my chatbot. Some of them makes more sense than other, but still, it was interesting to get a broad overview of what's possible. Okay, we are coming slowly to the end of the presentation. As a conclusion, I want to leave you with a few takeaways. The main one being that this solution based on an agent, a RAG, and external tools is highly adaptable. Take a moment to think that Alice is being used as an AI librarian right now, but if I take her, I change her prompt, and instead of the one I've been writing, I give her specifics about answering clients, helping them with their order, tracking parcels, etc. And instead of giving her access to Wikipedia and YouTube, I give her access to client accounts, parcel tracking systems, delivery orders, etc., etc. I can reuse the same architecture, the same structure, and actually create a customer service chatbot that would help your customers with any question they would have. The fact that we are using LLM like GPT-4 allow us now also to create chatbots with personality. So we are moving away drastically from the chatbot we used to have a few years ago. I don't know if you remember, but we had chatbot that sounded very robotic, that were repeating a lot themselves, that couldn't really help you. Like most of the time you had to ask to talk to a real person. But I was surprised lately when ordering something or booking a flight to come up to chat with a chatbot, and I was surprised how human actually the answer of the chatbots were. So by using LLMs like DGPTs and complex LLM, we can build chatbots with personality and actually work on engaging interaction and improve the way people are interacting with them. Finally, Langsmith and Giscard are very powerful tools. They are helped me a lot improve the chatbot, and I should use them to tackle the problem that are still resisting me. As you can imagine, 7 days is not a lot. There are a lot of steps Alice should go through. Mostly, she should be made more robust, especially to generating hallucination and harmful content. This is not something that should happen. So this is where Langsmith and Giscard are gonna shine and really help me improve and make her more robust to any queries the readers could ask to her. The latency should be reduced. You will see that Alice takes like 4 or 5 seconds to answer, especially when fetching information from YouTube. That takes a long time. The latency should definitely be reduced to get this feeling of an actual conversation happening. To cut her some slack, she's running on my 10 years old PC and fully on the CPU. So I'm not using any GPU right now, and all the calculations are running on CPU. So this is, in my opinion, still impressive that the solution is running, especially with the whole text-to-speech and speech-to-text happening in real time. So, but still the latency should be reduced. The UX, user experience, should be improved, especially the UI, and move towards a solution that one could deploy in the cloud, for instance. And finally, an important point is that this open source alternative should be evaluated. So initially, I really wanted to open source all side of her, but because of the 7-day deadline, I had to rely on solutions that were much easier and especially outsourced, like outside of my computer. So all the calculation linked to OpenAI GPT-4 or Mini are done externally, so this is much lighter for my computer. So the performance, the maintenance, the cost, all of these questions should be weighted to see if it's interesting to fine-tune, implement and fine-tune a model like Mistral or Llama and run it locally, which of course requires stronger hardware. If it's interesting to move towards this solution, or simply to rely on OpenAI calls, which are, let's be honest, very cheap today. But one important point is that by using open source alternative and fully local alternative, you could actually you could avoid relying on external application, on cloud knowledge, on calls to external API, and this can address privacy problem. This can be very important for some company who don't want their documentation to be outsourced, to be saved somewhere in the cloud, to leave the company. You could have actually everything into a black box, everything running locally, and you could implement a whole RAG agent, RAG LLM system locally inside your company walls. So this is also a very interesting topic that should be discussed. Bonus point, there was a bonus point to get in the project, and I got it by doing something I usually do, is that I centralize all of my project settings into a YAML file. This is a great habit I have to, every time I have a doc string, a magic string, every time I have a path or a model name, something, I centralize it all into a YAML file, and this YAML file is available into all my modules. Inside I can define my name, my chatbot name, some colors, some path, the main model I'm using, and the temperature, my summarizer, my relevance grader, my database information, embedding model, oops, the HTTPS voices, and some logging and chat history settings. So it's very handy to have everything here into one file, and especially it's not just fast to reach and modify, but it's also, it allows you to create templates, actually to have different YAML file for different use case and load them very fast. All right, thank you to the courageous one who stayed up to the end. We're going to do a quick demo of Alice now. I will put you in the video description the repo, the path to the GitHub project, and my LinkedIn if you want to connect. Last word, the project is right now in the state it was at the end of the 7 days, so I didn't do much work on it. The only two things I've done is that I optimized a bit the demo to reduce slightly the latency, and I implemented some feedback to see what tools Alice is using when she's fetching information. This is to spare you the ugly command line windows with all the tool calls. But for the rest, she's as she was at the end of the 7 days and of the bootcamp, right when I did the presentation. All right, without further ado, let's have a talk with Alice. There she is. I'm still gonna show you the command line so you can see the tool calls. Still interesting to see what's happening under the hood. Hey Alice, I brought some guests today and they want to know everything about you. Okay, you can see she's fetching information about herself.
Hello, I'm Alice, just like the character from Alice in Wonderland. I am a dedicated librarian who cherishes classic literature, always eager to welcome readers and delve into timeless stories together.
I'm gonna shush her because, I mean, while it's her job, she tends to speak a lot. Let's ask her for book information. Tell me about Journey to the Center of the Earth. Okay, she's going to her internal database. Perfect. Fetching information, summarizing it.
Journey to the Center of the Earth, written by Jules Verne in 1864, tracks the extraordinary expedition of Professor Otto Lidenbrock, his nephew Axel, and their Icelandic guide, Hans. Starting in Iceland's Snæfellsjökull volcano, they embark on a perilous adventure through Earth's underground world.
Kudos Alice on pronouncing Snæfellsjökull. Alright, so as you see, she fetched information from her database, summarized it, returned it. It's working great. What can we ask? Can you search for the main characters in Journey to the Center of the Earth? She should go to Wikipedia. Yes, usually when asking for main characters, she doesn't find them in the plot, so she's going to Wikipedia.
The main characters in Journey to the Center of the Earth are Professor Otto Lidenbrock, a passionate and somewhat temperamental scientist, his anxious nephew Axel, and Hans Bjelke, a stoic Icelandic guide.
As you can see, she went for Wikipedia and she summarized the Wikipedia page, but by focusing on the main characters themselves. So this is what why using an LLM-based summarizer is interesting to really focus the information based on the user query. All right, that was all for the retrieve information. Let's try to ask for information about book reviews. So that's a little bit more tricky. What we can do is we're going to fetch for this. I look for reviews about Journey to the Center of the Earth, and for example, let's take this review and see if we can discuss it with her. I want to discuss this book review. I'm using the text input so I can paste the link. Yeah, you see she's going to YouTube, obviously. She's reaching for the transcript, summarizing it, analyzing it.
The review reflects a lively discussion surrounding Journey to the Center of the Earth. The reviewer appreciates Jules Verne's accessible prose and the vivid details, particularly highlights from the later chapters filled with intriguing visuals and excitement, which they found delightful.
Okay, she's done a great job. She retrieved the transcript, summarized it, and she's able to answer a question about it. We can ask her a question. Did the reviewer like the book?
While the reviewer had mixed feelings about parts of the book, they ultimately appreciated the imaginative elements and entertaining moments.
She's not using any tools right now because she still has the transcript in memory, and she's able to answer about it. I can actually show you how the memory works. Journey to the Center of the Earth is my favorite book.
What a wonderful choice! Journey to the Center of the Earth captures the imagination with its thrilling adventure and vivid world.
Love the smiley at the end. Okay, again, she didn't use any tool. She's just doing chit-chat. Hey Alice, do you know what is my favorite book?
It sounds like I may have misspoken earlier. Yours is Journey to the Center of the Earth. It's a fantastic choice, blending excitement with remarkable exploration.
Okay, you see she remembers. Yeah, she just understood Alex instead of Alice. Yeah, my French accent doesn't help the DH, and STT engines. What else can we do? Let's do a last call using YouTube, but this time asking for broad reviews. Can you search for YouTube reviews about Journey to the Center of the Earth? Okay, she's going to YouTube again. This time she's going to fetch for more reviews. She's doing a YouTube search, Journey to the Center of the Earth. Okay, you see she found 3 of them. Summarize them.
Here are a few YouTube reviews about Journey to the Center of the Earth. One review titled Book Review, Journey to the Center of the Earth by Jules Verne highlights Dutch professor Hardwig von Hardwig and a character named Harry on their adventurous quest. The reviewer emphasizes the book's imaginative elements and encourages readers to explore this classic.
Okay, I'm not going to let you hear everything, but basically she's going through the 3 reviews and doing a paragraph. I ask her in a prompt to not list, like avoid listing, avoid putting bullet points, avoid stars, because the text-to-speech engine is actually reading any punctuation point and everything. So I ask her to summarize and just return me one answer into a few sentences. So as you can see, everything is working. We covered reaching for information. We covered checking Wikipedia, fetching reviews from YouTube, talking about a precise YouTube transcript. We showed that the memory is working. And yeah, think about it. Everything you can do with Alice at the moment. So that lets you imagine the possibilities that this system is offering. Thank you, Alice. This is the end of my demo. Can you say bye to everyone?
Thank you for joining me in this delightful discussion. I hope you found it enriching. A warm goodbye to everyone. May your next literary adventure be as exciting as a journey to the center of the earth.
Okay, I love that she's actually ending with the bug I talked to you about. She just started generating and blabbering some random. Oh no, or maybe that means something. Oh no, she got me curious. What is it? Sorry, I'm just checking on Wikipedia. I'm curious. What is this word? It means property. Okay. No, so that's a bug. Anyway, I'm happy that my actually pretty good demo, because it's very hard to go through all the steps without running into any bug, and everything worked well into the end, up to the last word. Well, that shows you that Alice has quite a lot of steps in front of her before being integrated into all of the libraries, and before you can actually meet and talk to her. That's it. That was Alice. I hope you enjoyed this demo, and yeah, feel free to have a look at the repo, contribute if you want, send me the use case you think that makes sense and where Alice would shine, and how you would modify Alice to be even more performance, or just fine-tune her to do a complete different task. Thanks for listening, and stay tuned for more content. Ciao, ciao.